In the heart of South America lies a land so grand, a nation filled with beauty, where dreams are in command, with golden sunsets painting skies and rivers flowing free. One Guyana, our homeland, where unity runs deep. One Guyana, united we stand, hand in hand, we'll build a land, from the coast to the savannas, the rainforest tall. One Guyana will rise above it all. From the mighty Essequibo to the Rupununi Plains, diverse cultures intertwined like rivers after rains. Oh, the colors of our people, a tapestry so bright. One Guyana, different faces, a harmonious sight. One Guyana, united we stand, hand in hand, we'll build our land, from the coast to the savannas, the rainforest all. One Guyana will rise above it all. This one Guyana, united we stand, hand in hand, we'll build a land, from the coast to the savannas, the rainforest tall. One Guyana will rise above it all. This one Guyana, united we stand, hand in hand, we'll build a land, from the coast to the savannas, the rainforest tall. One Guyana will rise above it all. In the heart of South America lies a land so grand, a nation filled with beauty, where dreams are in command, with golden sunsets painting skies and rivers flowing free. One Guyana, our homeland, where unity runs deep. One Guyana, united we stand, hand in hand, we'll build a land, from the coast to the savannas, the rainforest tall. One Guyana will rise above it all. From the mighty Essequibo to the Rupununi Plains.
Welcome back to our live broadcast of the National STEAM Fair 2025. To resume what we've been doing here, to recap what we've been doing here, we've been going around the booths showing you guys the amazing projects that the students here have to offer at the Architrong Conference Center where the National STEAM Fair 2025 is being held. Right now I'm at the J.C. Chandy Singh Secondary School with Rani, Ramaya and Bina. Here they're going to explain their project called Breadfruit Beyond. They're going to tell us a little bit about the project, what inspired this project, and what's the larger purpose of doing a project like this. So, ladies, what are we looking at here right now?
We're looking at, well, our project is entitled Breadfruit and Beyond, a nutritional shield against colon cancer. We're trying to prevent colon cancer in the Caribbean. So our project is based to prevent colon cancer, and all the stuff that you saw here is made from breadfruit. Now, breadfruit is rich in fiber, and studies show that a high fiber diet can reduce colon cancer in the body.
So our project is basically, so as you know, that colon cancer is a chronic disease that affects your bowels, and breadfruit consists of a high fiber content. Breadfruit consists of a high fiber content. So all of our breadfruit dishes were made out of breadfruit. We made 13 breadfruit dishes. We made breadfruit bread mix. We made breadfruit flour, cake mix, porridge. We made breadfruit ice cream, smoothie, etc.
So we made flour using a breadfruit. So we slice the breadfruit into thin slices, then put it in the sun to dry to absorb the moisture, and then we place it in the food processor to be milled to get the ground product you're seeing here today.
So guys, can you tell me, are these product being used by anybody outside of the school that you guys created in?
Yes, our parents has tried them already.
So you guys have heard it, right? The students of J.C. Chandy Singh Secondary School and their breadfruit project here is when it's vital. It's essential need to, prevent colon cancer throughout the entire Caribbean. So there's a lot more that we have to show you guys right here at the National STEAM Fair 2025. We're going to go around and, chat with a few more booths until 3 o'clock. And we'll come back here tomorrow to show you guys the closing ceremony of the National STEAM Fair 2025. We're going to head over to Shante as she interviews the next booth.
As we continue to delve into the various STEAM projects here at the annual STEAM Fair 2025, we're here with students of the Woodley Park Secondary School. And can you guys tell me your names first and foremost, and then tell me about your project?
Hi, my name is Ken Grusi, and this is my partner Marvin Drake. And today we will be talking about, our project is about Brassica bloom. And we want to enlighten not only farmers but the society that rice husk biochar is so healthier and more fertilizer to use for your plants. And it gives the plants minerals needed such as nitrogen, calcium, silica, and potassium. So we would like to encourage farmers and others out there to use rice husk biochar on your plants.
So basically, this is a more improved fertilizer, and it is showing here, I'm guessing this is the growth of the plant through how many weeks? 2 weeks. And are any of these without?
Yes,
this is without, and this is with
15, this is with 10, and this is with 5
gram, and this is without, and they're all 2 weeks old 2 weeks old plants. Awesome. Thank you very much for your project. Awesome job. And there we have it, the Woodley Park Secondary School with their project title, Brassica Bloom.
What if students held the answers to Guyana's future? Well, wonder no more, because innovation is taking center stage at the National STEAM Fair 2025. Presented by the Ministry of Education, this year's theme, Innovative Solutions Through STEAM for Sustainable Development in Guyana, is more than a motto, it's a movement. From April 23rd to 25th, this year's event features student-led projects from across Guyana, tackling real-world problems with real innovation through interactive exhibits, mind-blowing experiments, robotics in action, eco-friendly solutions, and creative art meets science installations that prove STEAM isn't just theory, it's action. Whether you're a student, teacher, parent, innovator, policymaker, or just plain curious, join us daily from 9 a.m. to 3 p.m., April 23rd to 25th. Admission absolutely free. Inspiration guaranteed. This is more than a fair, it's a front row seat to Guyana's next chapter. Are you ready to be amazed? The National STEAM Fair 2025. Be inspired, be there, be the future. What if students held the answers to Guyana's future? Well,
So we're at the
wonder
Maikoni
no
Secondary
more,
School booth
because
here, and their project is called Magnetize Water. To explain more about this project, we have Shaniqua and Shelton here, who's going to go through the process, creation, and purpose of this project. So, guys, what are we looking at right now? I'm seeing a shade house, I'm seeing a water tank. Explain to the viewers what this project is and what it's about.
So mainly this project is about, the goal is mainly to improve and enhance productivity and sustainability in agriculture using a shade house. So if you don't know what is magnetized water is regular water that passes through a magnetic field that alters its physical and chemical structure. So when the water passes through the magnetic field, the clusters breaks down. So the iron and the carbon breaks down and irrigates the system. Is a drip irrigation system, so it helps in faster germination, improves of nutrition uptake, and it helps in stress resistance.
Yeah, so as you can see, this is sample A and sample B. Sample A used magnetized water and it performed and grow much better than sample B, right?
So the project, in a nutshell, is to basically provide more cleaner, nutritious water to the crops so that they can grow healthy, correct? Yes. So you guys have heard it here from Shelton and Shaniqua here at the Maikoni Secondary School booth, and their project Magnetize Water to basically provide more cleaner, nutritious water so that we can grow healthy crops. So we've seen a lot here at the National STEAM Fair 2025 and at day 2. We've seen so far a combination of both days. We've seen turning mud into electricity. We've seen board games, mathematics board game. We've seen the use of technology, creating a website to scan QR codes and can do scavenger hunts. And there's more, I'm sure, to come. The excitement as we go along the line and interview the other booths here at the National STEAM Fair 2025.
And here we are this afternoon with students of the Maikoni Secondary School. Can you guys tell me your names and a bit about your project?
Hi, my name is Ashana Aaron.
Jonathan Prasad.
We're students of Maikoni Secondary School, and I will give you a brief explanation on what our project is about. The title for the project is Harnessing Wind. It's a wind turbine powered sewage system for water transportation. So we have designed and tested a system that could utilize wind energy and power a simple irrigation pump. For example, in Guyana, a small village of Hope, which is located on East Coast Demerara, they suffer from heavy rainfalls, flooding, and high tide, which pose a serious threat in the agriculture home. This area relies on fossil fuels and is very expensive. However, we have developed a system that is cheaper and way cleaner for the environment. Now, I will hand you over to my friend Jonathan, which will explain how the mechanism works.
Hello, good afternoon. Basically, I will just recap what Lashana said. The whole idea of this project is basically to reduce what fossil fuels being used in the agriculture sector. Because when using fossil fuels, it damages the environment. As you can see, the place getting hotter, everyone's sweating. Alright, so the fan will basically represent the wind. The turbine So the wind will turn the turbine, which is connected to a crank and then a rod to a syringe. The syringe can be think of as an artificial pump, right? Now, the syringe can be placed in a lake, a trench, wherever, right? Yeah. Has a body of water. So when the syringe pulls up whatever water there is, as the turbine makes a full 360 and compresses the syringe, it will have an exit location near the end of the syringe that can be led with PVC pipe or hoses to your desired location for water, irrigation and or drainage.
Now, who thought about this project?
Lashana.
And why did you think about it in the first place? Because of the situation with the Village of Hope?
And the farmers too, because they be suffering from flooding and they have to take buckets to dip out water, and that takes a long process. With our own, it's way quicker and way easier for them.
Awesome job. Thank you very much. And that is Maikoni Secondary with their project, Wind Powered. What is the name of it?
Harnessing the wind.
Harnessing the Wind. Thank you very much. Over to you.
The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
This fair shows that we as students can do amazing things.
It's inspiring to see what other students are doing. It makes me want to do even more.
What we're seeing here is proof that when we invest in our children, we invest in the future of Guyana.
I feel proud to be part of something this big. This matters. It feels amazing to be a part of something this big
and to have our creativity recognized on a national level. This STEAM fair empowers our youth to dream, to build, and to believe in the power of their own ideas.
Being here makes me feel like what we do matters.
and that we can shape the future.
STEAM is alive in Guyana, and it's only just the beginning.
School, a booth here, and they're going to show us their project, which is turning cassava into plastic, which is a really exciting concept. And I have with me Yuanse and Delisa, who's going to explain this project to us. So guys, tell us, what are we seeing here? I'm seeing in this plate what looks like plastic. Is this actually made out of cassava?
Yes, it's made out of cassava, glycerin, and vinegar.
So can you tell us what is the process that goes into making cassava out of plastic out of cassava?
So first we need to make the starch, which is a very easy process to make.
And then we grab the vinegar, water, glycerin, and heat it in a pot, and then we put it on plates to dry, and we mold out a bowl covering to make the plastic sheets.
So you guys were telling me when I first came here that these are also biodegradable, right?
Yes.
So what do you hope to achieve with making cassava out of plastic? Was there a problem that you guys were noticing?
Yes. Yeah. There is an increase in plastic pollution.
Right. So you guys have heard it here from the 2 Miles Primary. How old are you guys again?
10.
They're 10 years old and they're turning cassava into plastic. So, see, a lot of innovative ideas are coming out of the National STEAM Fair, not only by the secondary school students, but also by the primary levels. And they're coming up with some really innovative ideas. And you can only find these ideas right here at the National STEAM Fair 2025, happening today and tomorrow. at the Arthur Chung Conference Center. So come on down, bring a friend, bring a family member, come out with your entire family and look around the booths and come and talk to these kids as they explain these projects to you guys and what they're working on.
And we're here with students of the Abram Zoll Secondary School. Can you tell me your names and a bit about your project?
Hi, my name is Tifion Tucker. And my name is Hannah Rodriguez. Yes. So our project is based on, as you can see, a gravity generator. So this project is used to create electricity by the use of gravity. And we use a weight and pulley system which turns the gravitational potential energy into electrical power.
Demonstrate.
So they're about to do a demonstration.
So in these pulleys there is potential energy, and when the weight drops, this turns into kinetic energy, and it then converts to mechanical energy, which spins this turbine. It is then converted into electrical power and is stored as electricity in this storage unit, which is our battery. It is then used to power the lights on this school. It can also charge your phone. It could power a microwave. It could power a refrigerator. It can also power a whole rural community.
Awesome. And who came up with this excellent idea?
Us. We came up with the idea.
You came up with the idea. Any specific reason?
Well, there are other ways to create electricity, which is solar, wind, and water. But, they're not always there. They're not as reliable. Whereas gravity is abundant. It's always there. So, yeah, that's one of the main reasons.
Okay, thank you very much. There we have it. The students of Abram Zoll Secondary School with their project, the Gravity Generator.
We are at a place where by September of this year, we will be opening at least 20 new secondary schools across this country. And by mid-next year, we would have achieved universal secondary education across Guyana. I was saying to someone, only in Georgetown, we have built and are going to be opening shortly the new Christchurch Secondary, the new St. George's Secondary, the new St. Mary's Secondary, which I will let you into a secret now, will become the new Brigade Secondary. We have built back St. Rose's, which was broken down in 2017 and never built back. We've extended significantly Queen's College, Bishops, St. Rose's, St. Winifred's, East Rumville. We are currently extending Tocqueville, Campbellville.
So we're at Bath Primary School, and I have with me Aradia and Martha, and they're going to explain their project called Newsprint Nova, and they're going to basically tell us what this project is about. Oh, hi, girls. Can you tell us what we're looking at right now and what this project is really about?
So our project is about recycling of newspapers and turning newspapers into useful products.
And what are some of the products that we're looking at right now? Let's go through them. I'm seeing a platter here.
Yes, so we have platters, we have food bowl, we have plates, boxes, bowls, baskets, another basket over there, Easter hats, and more.
So how do you guys, you say you're using newspaper, right, to make these products. How do you guys turn it into what we're looking at today? How do you turn the newspaper into a hat?
First, we take a container, fill it with soap powder water. Then we take the newspaper and wash it all of the ink. Then we take a bucket of clean water. Then we take the newspaper again and chip it up with our hands so it will look like a blob.
Then we will strain it out with our hands, squeeze out the excess water, and put it in a blender to blender it. After we are finished blending it, then we put it back in the bucket of water. So then we take a sieve and then we place it in the water, and after that we take it out and we place it on a surface. Then we take the sponge to absorb all of the water, the excess water, and after that we put it in the sun to dry. After it's finished drying, you can take out the sieve and you will have an canvas. But if you wanted to get a mold shape of a bowl, you have to put it on a mold, cut out the excess, fold it in and put it in the sun to dry, and when it's finished drying, you have a mold bowl.
That sounds really interesting. It sounds like a very, very long process. Can you guys tell us what was the purpose of this project? Why come up with recycling newspaper?
To show how much paper is wasted in the community.
Right, so you guys have heard it from Aradia and Martha and their project called Newspaper Nova, which is basically recycling newspaper to make new products. I'm looking at them, seeing boxes, I'm seeing a hat, I'm seeing a platter here. So there's a lot of, like I've said, there's a lot of interesting projects we've seen so far. As we go along the line, every booth is telling a different story, using some other form of what STEAM means here at the National STEAM Fair 2025 happening at the Arthur Chung Conference Center.
Here we are with students of the Charity Secondary School. Can you tell me your names and a bit about your project?
Good afternoon, everyone. My name is Tabitha De Freitas, and my colleague here is Alicia Ali, and we are representing the Charity Secondary School, region number 2. Our category is Agriculture Science, and our project is based on turning feathers into feed, or basically turning waste into worth, which is the feather. So I'll now hand you over to my colleague Alicia Ali, who will explain more about the project. Thank you.
Good afternoon, everyone. So first, the process begins by collecting the feathers from the poultry farm after slaughter. After slaughter and you collect the feathers will be dirty. So it goes through a cleaning and processing. After the cleaning and processing, we add it to a pot of water with sodium hydroxide, and the mixture turns to a greenish color afterwards. And after 4 or 5 days, it starts to harden. And that's when we take it to the separation and drying, through the separation and drying. We use a pellet milling, and it comes out looking like this here. And for the smaller chicks, we use a grinding mill to make it smaller for them. Thank you.
Awesome. So basically, you're turning the waste from the meat birds into food for the other meat birds who are going to come after. Awesome work. And who thought of this idea in the first place?
Well, basically our teachers came up with a project so it can help us with our SBAs and research topics and so on. Yeah, basically it.
Awesome. And do you see this project taking off? Do you see it becoming something big in your community? Is it something you're going to take back to your community and implement in your community?
Yeah, I think it would work out well. It would help most small farmers to become independent, and it would help them save money.
Awesome job. Thank you very much, both of you. Very intelligent young ladies. And I trust that this project takes off as you wish it would. And also, I wish you all the best in the STEAM competition.
Thank you.
You're welcome.
What if students held the answers to Guyana's future? Well, wonder no more, because innovation is taking center stage at the National STEAM Fair 2025. Presented by the Ministry of Education, this year's theme, Innovative Solutions Through STEAM for Sustainable Development in Guyana, is more than a motto, it's a movement. From April 23rd to 25th, this year's event features student-led projects from across Guyana, tackling real-world problems with real innovation through interactive exhibits, mind-blowing experiments, robotics in action, eco-friendly solutions, and creative art meets science installations that prove STEAM isn't just theory, it's action. Whether you're a student, teacher, parent, innovator, policymaker, or just plain curious, join us daily from 9 a.m. to 3 p.m., April 23rd to 25th. Admission absolutely free. Inspiration guaranteed. This is more than a fair, it's a front row seat to Guyana's next chapter. Are you ready to be amazed? The National STEAM Fair 2025. Be inspired, be there, be the future. What if students held the answers to Guyana's future? Well, wonder no more, because innovation.
The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
This fair shows that we as students can do amazing things.
It's inspiring to see what other students are doing. It makes me want to do even more.
What we're seeing here is proof that when we invest in our children, we invest in the future of Guyana.
I feel proud to be part of something this big. This matters. It feels amazing to be a part of something this big
And to have our creativity recognized on a national level.
This STEAM fair empowers our youth to dream, to build, and to believe in the power of their own ideas.
Being here makes me feel like what we do matters.
and that we can shape the future.
STEAM is alive in Guyana, and it's only just the beginning.
We're at the St. Aidan's Primary School. They're coming all the way from Region 10, and they're going to tell us about their products called Activate Wonder Charcoal in Action. I'm with Michael and Angelica, and they're going to tell us a little bit about their project. So I'm seeing charcoal on the table, I'm seeing a painting, and I'm seeing jars here. Guys, tell us what we're looking at right now.
So they're activated charcoal. The activated charcoal was used to make soap, was used to paint, was used for water filtration, for face mask, and toothpaste.
And can you guys tell us what's the process of, turning charcoal into soap, into toothpaste? What's the process of that?
First, to make it into soap, you have to use water, sodium hydroxide, olive oil, sunflower oil, castor oil, and eucalyptus oil.
And can you also tell us what product is used to make the charcoal? Is there a specific type of tree that you guys use or plant that you guys use to make the charcoal?
The charcoal was made by burning coconut shell. After burning the coconut shell, we leave it to cool off. After it was cool off, we squeeze lime juice on it. After the lime juice was on it, we leave it for 24 hours. After the 24 hours, We wash out the lime juice, the scent from the charcoal, and then we leave it to dry. After it's dry, we crush it, and then we have activated charcoal.
And can you guys tell us what's the purpose of having a project like this? Why choose charcoal to show that you can make soap and paste and all this kind of stuff with it?
Because charcoal is clean, the coconut shell is non-toxic. Some would have toxic chemicals that can be harmful.
All right, guys, so you've heard it from Michael and Angelica here at the St. Aidan's Primary School booth, and their project called Activate Wonder Charcoal in Action, and they're using charcoal to make a wonderful, a lot of products like soap. It can be used for painting, toothpaste, and whatnot. So there's a lot of more booths that we have to cover here at the National STEAM Fair 2025. So stick around. We're going to be here all day.
And we're here with the second batch of students from the Abram Zool Secondary School. And can you tell me your names and a little bit about your project today?
So my name is Luana Gopal.
And I'm Mira Surendra.
So our project is based on purifying agricultural wastewater using electrocoagulation and oxidation. So here we have a sample of some water. So we use this pump to carry the water to the sedimentation unit, and in this unit large debris settled to the bottom. After that it goes to the filtering unit. Here large particles are filtered, and here we have a strainer, which is a reliable way and a very sustainable solution instead of spending a lot of money. This is a cheap alternative. Next, it goes to the electrocoagulation unit. Here we have two metal sheets of iron and aluminum. Here, I will hand this over to my colleague.
In the electrocoagulation chamber, with the use of iron and aluminum, we uses electrolysis to create electricity to help purify the water. With the use of iron sulfate, we add to the water. It helps to clog the dirt from the bottom of the water, which creates manure. This is our end product of manure. Manure can be used for agriculture purposes, for example, putting on plants. In the electrocoagulation chamber, the irons are known as the cathodes and the aluminum is known as the anodes. So basically, cathodes is the reduction of electrodes and anodes is the gain of electrodes known as oxidation. Water is then pumped to the oxidation unit. The oxidation unit is important. With the use of hydrogen peroxide, we purify the water. Hydrogen peroxide is being poured into the oxidation unit. This is so because hydrogen peroxide melts the irons, which purifies the water. The water is then poured into the chlorination and aeration unit. In the chlorination and aeration unit, water is being purified by adding chlorine. Furthermore, the water is being pumped out. After pumping out, the water can be used for agriculture purposes. For example, poultry. It also can be used for domestic purposes, for example, washing houses. So that's basically it. But our aim is to purify agriculture wastewater for agriculture purposes, not for consumption. But if we would like to purify water for consumption, we would visit electrohydrogen, electro H2O distillation industry. Thank you.
Awesome, good work. So it's basically you're tackling two matters here in one. You're first of all getting manure from this process, and also you are getting distilled water for agricultural purposes, as you made very clear, not for consumption, right? So these water, or the water we see as a representation here, is water that has been distilled from this process. Okay.
That's the before, this is the before, and this is the after product. And we've created our own label also. So it's H2O.
And there we have it, the students of the Abraham Zul Secondary School with their very sustainable innovation called the Electro H2O. Awesome job, a brilliant job, young ladies. I wish you guys all the best.
So we're here at the Tiger Pond Primary School, and I'm with Elijah and Kelsey, who are going to explain their project called the Number Magic Board. So Elijah and Kelsey, I'm seeing a lot of numbers on this board. Can you tell us a little bit about the project?
Yes, sir. Yes, sir. Well, as you know, my name is Kelsey Laika Jackson, and this is my colleague.
My name is Elijah Eliezer LaRose.
We are representing Tiger Pond Primary School, Region Number 9. Our project is entitled The Number Magic Board. We know that our learners were having difficult time solving most of the problems in our school. We have created the Number Magic Board from disposable waste found in our environment. We use cartoon boxes, foams, etc. On the aid, our numbers are ranged from 1 to 100, and it can be used to grasp different concepts in mathematics, such as odd numbers. Odd numbers are numbers that cannot be divisible by 2, always end with 1, 3, 5, 7, and 9. Smallest odd number, 1, largest, 99. Even numbers. Even numbers are numbers that can be divisible by 2, always end with 2, 4, 6, 8, and 0. Smallest even number, 1, largest. Smallest even number, 2, largest, 100. We can also learn about multiples of 3. The multiples of 3 are 3, 6, 9, 12, 15, 18, and much more. Using this, we can also learn about common multiples of 2 numbers. For example, common multiples of 3 and 4. Common multiples of 3 and 4 are 12, 24, 36, and much more. The LCM of the 2 numbers is 12.
Using this, we could find prime numbers. Prime numbers are numbers that cannot be divisible by any other number except 1 and itself. We could use it to find any other concept in mathematics, such as the magic square and before and after.
So guys, there's a lot that we can use for the Number Magic Board. You guys said we can do even numbers, odd numbers, prime numbers, magic square. Is this project currently being executed at Tiger Pond Primary School?
Yes, sir.
So can you guys tell us who came up with the concept and the idea for such a project that is really, really helpful to students?
Actually, the whole school. The whole school came up with this project.
So guys, as you can see at the Tiger Pond Primary School, they and their the Number Magic Board, which can help students learn multiple mathematical concepts, only happening here at the National STEAM Fair 2025.
And we're here with students of the Port Kaituma Secondary School. Can you guys tell me your names and tell us a bit about your project?
Hello, my name is Aisha Menonza, and this is my colleague, my friend. She will tell you her name.
My name is Julissa Pear.
And okay, so I will tell you a bit about our project. So what you're looking at here, what we have here is called a solar powered desalination plant. So this is the water source, this is the reflectors, this is a container that contains the contaminated water, and inside this container has a smaller container which is the collection container, and over here it has a reservoir. So what is desalination? Desalination is a process whereby any contaminated water is purified into clean water, specifically for drinking. Our project focuses on purifying water for drinking. So I will tell you what the process is like. So first, it has a lot to do with the solar energy. When the sun shines, it shines onto the reflectors, which reflects the light onto this container, the black container. The black container, which has the contaminated water, then gets heated and then the water starts to evaporate. When it evaporates, it leaves all the salt, dirt, and harmful bacteria behind, all the impurity. Just the water vapor rises because and no solid can evaporate. So when that happens, this plastic traps the evaporation from escaping. And then eventually the water vapor will condense, meaning that it go back into a liquid form and then gently goes into the center and back into the collection container. In the collection container has the clean water, the pure water for drinking, and then whenever that is filled, it is transferred to the reservoir for storage and use. So that is basically our project. We chose this project because in our community, many households struggle to access water that is both available and safe for drinking. So this is why we came up with this project, because we want to help people to access water that is safe for drinking.
Awesome. So this water that is in front here in this container, you'd say that it is distilled water. It's good for drinking. All right, awesome job. There we have the Port Kaituma Secondary School with their desalination chamber, or rather their desalination plant, and they're basically taking contaminated water and they're purifying it for consumption. Awesome job. Thank you very much. I wish you all the best, ladies.
The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
This fair shows that we as students can do amazing things.
It's inspiring to see what other students are doing. It makes me want to do even more.
What we're seeing here is proof that when we invest in our children, we invest in the future of Guyana.
I feel proud to be part of something this big. This matters.
It feels amazing to be a part of something this big
and to have our creativity recognized on a national level.
This STEAM fair empowers our youth to dream, to build, and to believe in the power of their own ideas.
Being here makes me feel like what we do matters.
And that we can shape the future.
STEAM is alive in Guyana, and it's only just the beginning.
We're here with students of the Good Hope Secondary School. Can you give me your names, please, and tell us a bit about your project here today?
So my name is Nicholas Martin, and this is my This is my colleague Dil Chandrika, and like you said, we're from Good Hope Secondary, and today we're competing in the physics category under the upper secondary division. I'll hand it over to my colleague and he'll tell you a little bit about our project.
So this is our electronic compass, the project that we came up with. But before we get into the electronic compass, we need to first get into the traditional compass. Well, you see, with the traditional compass, we face a lot of errors. For example, needle not embedded properly, which will lead to slipping, and pencil not tight, so it will eventually fall. But with the electronic compass now, this revolutionized the traditional compass with a motor, a motherboard, and a battery. So with the motherboard, now the motherboard sends the action which it order with direction it have to goes in to the motor, if it's going back or forth. So, and then there's a controller here which will control it. So with just a flip of a switch and a touch of a button, you can control it in which direction you want it to go in. And this is beneficial to all aspects of STEAM because it have the measurements here which will easily be adjustable. You could replace this with a marker or a pencil. And yeah, basically it.
Awesome job. So I'm guessing that you've encountered issues with your compass, hence you came up with this idea. This is what inspired this idea. Awesome job. Now, who was the brain behind of the operation?
We just sat down one day and was like, what will happen if we put a motor on a compass and just see what will happen? And then there it all happened.
And this just came to mind, step by step.
Yeah.
Okay, awesome job. And how do you feel about the competition thus far? Do you think you have this in the bag?
Yeah, I have this in the bag, but we have tight competition, so we're up there though.
Awesome. Totally love it. And this is our students of the Good Hope Secondary School with their take on the compass. Well, it's a revolutionized version of the compass. It's the electronic compass. Can I call it that? What can I call it? Yes, the electronic compass. So good job. Awesome, brilliant work. And I do wish you guys all the best.
We are at a place where by September of this year, we will be opening at least 20 new secondary schools across this country. And by mid next year, we would have achieved universal secondary education across Guyana. I was saying to someone, only in Georgetown, we have built and are going to be opening shortly the new Christchurch Secondary, the new St. George's Secondary, the new St. Mary's Secondary, which I will let you in to a secret now, will become the new Bridam Secondary. We have built back St. Rose's, which was broken down in 2017 and never built back. We've extended significantly Queen's College, Bishops, St. Rose's, St. Winifred's, East Rumville. We are currently extending Tocqueville, Campbellville, Secondary, all over this country. In Region 1, we're currently building 5 secondary schools.
You have to count me down, right? We are at a place where by September of this year, we will be opening at least 20 new secondary schools across this country. And by mid next year, we would have achieved universal secondary education across Guyana. I was saying to someone, only in Georgetown, we have built and are going to be opening for. We're here with students of the Tagore Memorial Secondary School. Can you tell me your names and tell me a bit about your project?
My name is Sean Kandala and this is my colleague Justin Ramjiwan. Our project is about methods to cure oil spills. So, we recently, about 10 years ago, Guyana has discovered oil, and there when drilling the oil, for the oil, there can be oil spills. It's possible they have possibilities to have oil spills. There are methods to cure the oil spills like bioremediation, where microbes break down the oil, but it takes a long time to do. And skimmers, where machines extract the oil, but it's very expensive and don't work well in rough conditions. Yeah, so we came up with a bagasse method. Can you tell a little bit about bagasse?
So bagasse is the byproduct of sugarcane after the juice has been extracted. It is fibrous and highly absorbent. So here we have a oil spill. Here the bagasse is applied to the oil spill, and after removing it, as shown here, the oil is absorbed and into the bagasse. Here we have the water afterwards. So here we have residue of the bagasse in the water, but that wouldn't be a problem because it's biodegradable and not harmful for nature.
So basically, this is your solution to an oil spill. All right. So who came up with this brilliant idea?
Well, there were farmers that weren't using the bagasse. They said they use the sugarcane, they extract the juice for selling, and the product is left with dry sugarcane. And they incinerate it and just throw it away. So we were thinking of a solution to this. So we came up, why not use it to cure oil spills? So you use the incinerated sugarcane to cure it.
Awesome. Thank you very much. This is an excellent brainchild, and I trust that it takes off and goes exactly where your idea, your very small idea now, grows into something very, very big. Thank you very much. And there we have our students of Tagore Memorial Secondary School with their solution to an oil spill. Thank you. So just now your card been cut out, so I'm not sure what's going to happen. So tell them that you.
The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
This fair shows that we as students can do amazing things.
It's inspiring to see what other students are doing. It makes me want to do even more.
What we're seeing here is proof that when we invest in our children, we invest in the future of Guyana.
I feel proud to be part of something this big. This matters.
It feels amazing to be a part of something this big
and to have our creativity recognized on a national level.
This STEAM fair empowers our youth to dream, to build, and to believe in the power of their own ideas.
Being here makes me feel like what we do matters.
And that we can shape the future.
STEAM is alive in Guyana, and it's only just the beginning. The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
We're at the Cotton Tree Primary School here, and they're going to tell us about their project called the Flamboyant Math Flare. I'm here with Lemuel and Dante, and they're going to explain what we're looking at here. So I'm seeing, let me run Dante. I'm seeing a domino set. I'm seeing a portal. Can you guys tell us what we're looking at and what this project is about?
This project is mostly about to help the children in our school to engage in mathematics concepts which are hard to them, but the flamboyant fruit comes with a very, very special seed that allows us to make mathematic concepts from topics to help the children engage and make mathematics more fun and creative to them.
So we have here, if you can see here, we have skip counting, one over here, one over here. And in the middle right here, we have Roman numerals. Over here, you can see the connection canvas. We have some shapes over here.
We have this. This is called the Bead Smart.
The Bead Smarts. The portion portal. The clock. And over here you have the domino den. No more nuggets over here and here. So let's start with the skip counting. Over here you can see 3, 6, 9, 12, 15, 18, 21, 24. Here we're skip counting by threes. And we can ask the children to go over 24, what would be the next number after 24? If you keep adding that number, the answer will be 27 because 24 plus 3 is 27. 27. Same thing goes for this one. You can ask them what goes after 12. We're adding 2 because 2 plus 2 is 4 plus 2 is 6, plus 2 is 8, plus 2 is 10, and then 12. 12, 14, then 16. We can ask them what goes after 16, which is 18. Now we have Roman numerals. We can ask them what Roman numerals mean, and we can tell them the rule. The largest Roman numeral has to be at the back, and the smallest has to be in front. That way we add. If the larger Roman numeral is at the front and the smaller is at the back, we subtract. Example, LX, L is equal to 50, X is equal to 10. 50 is greater than 10, so we subtract, and that'll give us 40. So XL is 40.
So a lot of interesting stuff happening with the skip counting and the Roman numerals. Can you tell me what does the connection canvas do?
The connection canvas helps children to learn more about shapes and the perimeter. So let's say we form a rectangle on the canvas. So we ask them how many seeds are formed around to make that rectangle the perimeter. So we ask them, and if they get the answer correct, they get a prize. So for the shapes, we ask them to estimate how many seeds were used to go around and fill around this rectangle. Then we ask them the area and the perimeter. We can even ask them what is the interior angle, which would be 360.
So there's a lot of exciting stuff happening with the flamboyant math flair at the Cotton Tree Primary School booth right now. So as you guys see, there's a lot of projects, a lot of interesting projects really happening here, right here on the ground at the National STEAM Fair 2025. We've been around the booths, we've seen a lot of stuff with the Caucasian crow. We've seen a mathematic board game. We've seen a mathematic box that helps you learn prime numbers, odd numbers. And now we're here at the Cotton Tree Primary booth, and we're learning how the flamboyant, the seeds and the flamboyant fruit can also help with, counting Roman numerals and even estimating areas for shapes. So stick around. We're going to be here up until 3 at the National STEAM Fair 2025.
We're here with another batch of students from the Abram Zool Secondary School. Can you guys tell me your names and tell me about your project here today?
So hi, my name is Indir Narain.
My name is Livia Stahl, and we are here representing Abramsville Secondary School in Region Number 2, Essequibo Coast.
So our project title is Waste Wires, turning discarded plastics into energy, electrical and mechanical, and building materials, right? You may ask, how do we do that, right? So I will tell you all about that. So we went around our community, and we noticed these issues. We have plastic bottles contaminating the drains, the trenches, right? So we came up with a solution for all of that. So right here we have our project, which eliminates all the plastic from our environment. So firstly, we go to houses and we give them garbage cans, and we pay them X amount of money, like within a week or so after coming back. And we collect the garbage and we bring it to our factory here, right, our little factory. So we have a furnace here. We put the plastics in the furnace to burn, right, at 350 to 450 degrees Celsius. While burning, you may think that we're contaminating this atmosphere by releasing the smoke, right? But no, we're not. We have a system in place for that. So here, we have a bottle called a cooling chamber, right? So the cooling chamber, the smoke comes in here and it cools the gas using the cryogenic separation technique, right? That's basically what it means, cooling gases and separating. So we have the different gases that we get from plastic while burning. So the first gas is carbon monoxide, dioxin, furan, hydrogen, methane, and carbon dioxide. You may think that we're still polluting this atmosphere by releasing these gases, but no, we're not. We have uses for each gases. For example, carbon monoxide, we use it to make pesticides. Dioxin, we have medicine, we use it to make medicine. Furan, we have antibiotics, we use it for making antibiotics and medicine. Hydrogen for making fuel, methane for fertilizers, and carbon dioxide from refilling fire extinguishers, right? Coming back here to my furnace, I have a steam chamber here filled with water. So while the water burns or boils, the water boils, right? The steam is transferred through this tube, which spins this turbine here, connected to an alternator that generates electrical energy, as mentioned in our project title, right? So that's how we get one part of the project, right? So then we have excess steam coming out here. We have a steam engine here, which generates mechanical energy. That's the second part of the aim of our project. So this is a little demo of how it works when it's heated up. Coming back again, so our turbine here, we of course we will have condensation happening here. So the water drips down and it turns to distilled water. Okay, we have distilled water happening here, coming out from this project as well. So again, to my furnace, after burning plastic ash, after burning plastic, we would have ash. This is a sample of what it would look like. And this is it, grinded up. So we have a mixture. We mix it in cement and sand, right, to form hollow blocks, right? So we're not only getting one thing out of this project, we're getting multiple stuffs out of this project, right? So this hollow block is our hollow block that we made ourselves, and this is a regular hollow block. This is very much lighter than this, right? So this hollow block is made with cement, sand, and ash, as I mentioned. So 8 pounds of sand, 3.5 pounds of ash, and 1.5 pounds of cement, right? So this is much lighter. It will not strain the foundation, right? Constructors will use less cement, right? And also, they won't have a problem lifting it and carrying it to higher places, like buildings where they're building. So I will now hand you over to Livia to tell you the rest about our project.
You might be asking, how does our project relates to STEAM? As in the word STEAM, science category, the separation of gases in the cryogenic technique we use to get the different sorts of chemicals. T, that's for technician. We do research to get our information about these things because we need it to be true, and possibly if we can get a facility like this in Guyana, we could develop our country even more and it can become richer. E, engineering. We obviously build the turbine and the steam engine. A, art. The project itself is an art. And M for mathematics, the calculations we did to get those graphs to show that everything we did here was actually true. We can't come up with random numbers and generate things for our project. And you might be asking yourself, how does our project relate to the theme of this STEAM Fair 2025? Innovative solutions through STEAM for sustainable development in Guyana. If Guyana considered this project to be facilitated in here, we could actually create a more cleaner environment, cut down on fossil fuel use, and extend the lifespan of our oil reserves. And this concludes our presentation for our project.
Awesome job. I like to give you young ladies a round of applause, but I don't have too many hands, so give yourself a tap on the shoulder. It's an amazing job, a job well done. I must say that you guys are not just focusing on finding solution to one issue, but many issues here, since you guys are even having distilled water from this project. Apart from that, you are creating byproducts like hollow blocks. Apart from that, you are also creating electricity or generating electricity, which will be of course beneficial for an entire community if this is something that is catapults. So awesome job, very great initiative, and I must say keep up the good work, and I wish you the best.
Thank you.
You're welcome.
So we're at Whitewater Primary School, all the way from Region 1, and I'm with Jazlia and Shamiza, and they're going to explain to us their project called QR Glometry City. So Jazlia, what are we looking at? I'm looking at a kind of a model of Georgetown. I'm seeing the Lighthouse, Pegasus Hotel, Starbrook Market, but I'm also noticing QR codes being placed along these buildings. What is this project about?
So this project is mostly about solid shapes. And for example, here we can see the Humaniana, and it is in the shape of a cone. And we also have the Georgetown Public Hospital here, and it is in the shape of a cube. And as you can see here, we have solars that you can use, and it also powers the project and also powers the circuit. And the circuit, for example, when you press the cuboid, a part of the Starbrook Market lights. And the QR codes here, as you can see, when you scan it, you can see fun games and quizzes that you can use to interact with students. And this can teach the students more about the shapes and more about mathematics. And a few of the buildings are Humaniana, Georgetown Public Hospital, and Starbrook Market. And we also have a few plain shapes. We have an octagon here, a triangle, and we also have the clock is a circle. And as you can see here, on the floor and on the walls, we have different games, puzzles, word search, and this shape game. Students can play it so that they can create fun things out of shapes, find the words, and you can also play this game and it shows you different shapes on it.
Thank you so much for that, Jazlia. So we're looking at a project, the QR Geometry City, which basically, if you click the switch on the circuit, whichever...
It has names next to it that can show you which is which. So the shapes here, for example, the cube, the Georgetown Public Hospital.
That will light up if I click that, and that as this lad just light up. So you see, again, there are a lot of really cool ideas coming out of the National STEAM Fair 2025, and we're seeing a theme here with the within the primary schools. They're coming out with their mathematical program, mathematics projects to basically help students better understand mathematical concepts in the classroom. So there's a lot more to come here at the National STEAM Fair 2025.
And we're here with students of the Marian Academy, and they have two projects here that they're presenting. But we'll start with the very first project, the project on my left. Oh, yes. And tell us your names and tell us about your project.
Okay. So my name is Samaya Sitar, and I'm Tremaine Clark. Our project is a soil moisture sensor, right? So what it does is it measures the amount of water in the soil. Tremaine will run you through the components, and I'll tell you why it's working the way it does and the sustainability of it, right?
Thank you. So this is a multimeter, and for this project is measuring the voltage. These are batteries, a breadboard, LED lights, some resistors, and the NAND logic gate. Can you hold this for me?
Okay.
How this works, you have to insert two probes within your soil, like this. And if your soil is dry, then your LED light will turn on and you can see the voltage on the multimeter. But if your soil is wet, then your light would turn off and the voltage on the multimeter would reduce, indicating the presence of moisture in your soil. And so therefore you do not need to water your soil anymore.
Okay, so this works because of the NAND logic gate, right? So water is a very good conductor, so you'd assume that the light would turn on instead of off. But that's not the case, right? So our NAND logic gate, what it does is it takes two high inputs and creates a low output, right? So it takes the high input from the moisture in the soil and creates low output, turning the light off, right? On the other hand, the dry soil has a lot of resistance, so it gives us low inputs, which any form of low input would give us a high output, turning the light on, right? Indicating that this soil needs a bit more water, right? Sustainability-wise, we're trying to use this for agriculture, so it helps us find that sweet spot where we're not wasting any water, because the goal here is to conserve water, right? So where we're not wasting any water, but we're also not sacrificing the health and quality of our crops, right? Because agriculture is a very big part of Guyana's economy, right? Especially with the crops we produce, like sugarcane and rice, both of which are crops which require a lot of water, right? So that's our project. Thank you.
Awesome sauce. Now I'd like to hear from my friends that are hiding away at the back. Can you guys tell us a bit about the inspiration for this project, and tell us a bit about how you even came to even make this project in the first place? What was the process like onto?
So our process started with all of us having the issue with watching our parents' plants, as most of us have parents at home that indulge in gardening or having kitchen gardens. And we collectively came up with this plan, since most of us were really prone to overwatering our plants and making them die, making our parents mad. So with the assistance of our physics teacher, Sister Meg, she helped us create this project to help with that.
Awesome. So no more dying plants from being over moisturized. Okay, awesome. Thank you very much. We're moving on to our second group. And our second group, give me your names, please, and tell us about your project.
I am Anya Alvin. And I am Angelina Yap. And our project is a solar-powered water desalination system. So it's a way of purifying water using the sun's radiant energy. So if sufficient radiant energy is applied to the water, then it will vaporize, leaving the solid impurities at the bottom. So this will make the water safe for human consumption. So these two containers, when they're exposed into the sunlight, since black is known as an excellent heat absorber, it will immediately start absorbing heat, allowing the impure water, which is inside the container, to vaporize and condense at the top, which the clean, fresh water will be at the top on the seal, and the impurities and sediments will be left at the bottom. This here creates a low point in the seal, allowing the water to drip towards it and into the funnel, which it is connected to the collector. So all the fresh water will be transported to the collector. On the other hand, the white is a heat reflector, so it will do the same but on a longer period. This is a very safe way to purify water since it doesn't contain any harmful chemicals and helps to reduce the burning of fossil fuels. So this water, which is in the collectors at the front, it could be used for household or domestic activities, and it could also be used for agriculture. But when it comes to drinking, it depends on the water which is inside the container beforehand, if you will have to add chlorine or anything to help purify it. Thank you.
Awesome project. And who came up with this brainchild?
The whole group, we all had an inspiration. Since Guyana has areas where we're not receiving water, we decided to make something that can help them.
Awesome sauce. I wish you all the best and keep up the good work. Over to you.
So we're at the Messiah Primary School and I'm with Maya and Fawaz, who's going to basically explain their project here. I'm looking at what looks like a home right now with a lot of systems going on. So Fawaz, tell me what we're looking at right now and what's the purpose of your project?
So we are looking at an automated fire safety system, and this system is basically we use modified sprinklers that put out fire. So basically if we light something inside, the smoke sensor inside will detect the smoke, and the sprinklers will shoot out water, which will out the fire, which will prevent the fire from burning down the school.
So this is a sprinkler system that you guys have implemented that once it detects smoke, it will automatically activate, correct?
Yes.
Maya, can you tell us a little bit more about the project? What was the idea behind creating something like this?
I feel like it's a great idea creating something like this, and this is what you're looking at. It's an automated fire safety system, and I think it's a very, very great idea.
Can we have a live demonstration of how it works?
Demonstration? Okay, we can.
So we're going to have a live demonstration of how this automated sprinkler system works right now. So they're going to light what looks to be like a tissue here. Kids, do not try this at home. So we're lighting and we're seeing the fire, we're seeing smoke. So it's lighting and so it's smoking and it works, guys. So that's the automated sprinkler system from Messiah Primary School. So there's a lot of cool projects right here happening at the National STEAM Fair 2025. So once again, I encourage you guys, we have one more day of the fair remaining. Come on down, bring your family, bring your friends, and interact with the students here at the National STEAM Fair 2025 at the Arthur Chung Conference Center.
The National STEAM Fair 2025 brought together young minds from every region, united by innovation, curiosity, and the drive to make a difference.
This fair shows that we as students can do amazing things.
It's inspiring to see what other students are doing. It makes me want to do even more.
What we're seeing here is proof that when we invest in our children, we invest in the future of Guyana.
I feel proud to be part of something this big. This matters.
It feels amazing to be a part of something this big
and to have our creativity recognized on a national level.
This STEAM fair empowers our youth to dream, to build, and to believe in the power of their own ideas.
Being here makes me feel like what we do matters.
And that we can shape the future.
STEAM is alive in Guyana, and it's only just the beginning.
And we are here with students of the Lebon Intention Secondary School, our final group of students for today. Tell us your names, please, and a bit about your project.
Hello, good afternoon. My name is Yugita Balarup.
My name is Mariana Tiloki.
And my name is Josephine Holder. And our project is a solar desalination system. Our goal is to find a sustainable solution for farmers facing water scarcity, particularly those relying on seawater for irrigation. Good afternoon once again, and I'll be telling you how the project will be working. So here is where the seawater is. There's a pump inside here. We then use the pump to pump the water into this boiler. The boiler then heats up, making water vapor, which passes through this hose, leaving the salt behind into this boiler. After the vapor passes through this pipe, it goes into this condenser, which cools it down and goes in to the collection tank. There's a pump inside this collection tank, which when we put on, it pumps the water onto this little garden here, giving it a drip irrigation. We don't want the water to be coming out flush so that it could fill up the farm, drowning our crops, so we put a drip irrigation instead to dam the soil. Also too, this here is a storage tank. We use it to store excess of the fresh water that has already been processed through this project here, and we can also give it to the animals on the farm. Thank you.
So this project is strictly for agricultural consumption and not for the consumption of humans.
Correct.
This water isn't tested, so humans cannot drink it. As you can see there, it's an example. The plant that is dried is the plant that we use seawater, so as you can see, it's dried. And the other two is that we use with our project for testing. Thank you.
Awesome. So you can definitely say that your project is a success.
Yes.
Awesome. I love it. And who was the brains behind the operation?
We actually put ideas together.
So all three of you put ideas together and came up with this idea. Okay, so do you think that you got it in the bag for the competition?
Yes.
I love the optimism. And there we have our students from the Lebon Intention Secondary School with their desalination project, and that has brought us to the end of today's STEAM Fair project, where we've delved into various projects here today. We've seen many innovations. Of course, we've also seen sustainable developments that will go on to be used in the future and in our country to make our Guyana better. We will continue coverage tomorrow for the STEAM Fair project, and we will also be covering the prize giving ceremony and the ceremony which also wraps this up and bring our 16th annual STEAM Fair to a conclusion. So do tune in for that. At this time, we're saying bye-bye and do enjoy the remainder of your day.
What if students held the answers to Guyana's future? Well, wonder no more, because innovation is taking center stage at the National STEAM Fair 2025. Presented by the Ministry of Education, this year's theme, Innovative Solutions Through STEAM for Sustainable Development in Guyana, is more than a motto, it's a movement. From April 23rd to 25th, this year's event features student-led projects from across Guyana, tackling real-world problems with real innovation through interactive exhibits, mind-blowing experiments, robotics in action, eco-friendly solutions, and creative art meets science installations that prove STEAM isn't just theory, it's action. Whether you're a student, teacher, parent, innovator, policymaker, or just plain curious? Join us daily from 9 a.m. to 3 p.m., April 23rd to 25th. Admission absolutely free. Inspiration guaranteed. This is more than a fair, it's a front row seat to Guyana's next chapter. Are you ready to be amazed? The National STEAM Fair 2025. Be inspired, be there, be the future. What if students held the answers to Guyana's future? Well, wonder no more, because innovation is taking center stage at the National STEAM Fair 2025, presented by the
We are at a place where by September of this year, we will be opening at least 20 new secondary schools across this country. And by mid next year, we would have achieved universal secondary education across Guyana. I was saying to someone, only in Georgetown, we have built and are going to be opening shortly the new Christchurch Secondary, the new St. George's Secondary, the new St. Mary's Secondary, which I will let you in to a secret now, will become the new Brigade Secondary. We have built back St. Rose's, which was broken down in 2017 and never built back. We've extended significantly Queen's College, Bishops, St. Rose's, St. Winifred's, East Rumbell. We are currently extending Tocqueville, Campbellville, Secondary, all over this country. In Region 1, we're currently building 5 secondary schools.